Okay, I guess let me begin. I'm Shikha. I teach middle school and IGCSE math at Valistus International School, Bengaluru, and welcome you all aboard. And as you all know, we have gathered here to discuss whether and how technology could help achieve the goals of school education. We all know that goals of school education is a very vast topic and means different things to different people. We may therefore focus on limited prominent goals and make an effort to find ways of achieving them. Hope we make some progress in finding some solutions. So, without much delay, let me introduce the speakers of the day. We have amidst us Sir Arun. Sir Arun Warhadpande served in the electronics branch of Indian Air Force for over 20 years, where he was involved in integrating mini computers with radar systems and a number of instructional assignments across all levels and all branches. After voluntary retirement from the Indian Air Force in 1987, he was totally involved in establishing computer departments in schools, including curriculum designing, selecting, and training of the staff. He has authored more than a dozen books on computers and information technology for school children from grades 5 to 12, published many articles on IT education in various magazines and newsletters as well. So today, let us take his expertise and understand from his vast experience. The second speaker of the day is Mrs. Punam. Mrs. Punam Pant is a mathematics graduate and a postgraduate in computer applications from Delhi University. She has an impeccable academic record and is also an NCERT National Talent Scholar. She has qualified the UGC NET exam for eligibility of lecturership. She has worked as a research engineer at the Center of Development of Telematics for 3 years and has taught computer science to senior school students in reputed schools for more than 20 years. She was part of the committee that formulated the computer curriculum for Army and Army public schools. She was also a co-author for a series of computer books titled Fundamentals of Information Technology, published by Frank Brothers under the aegis of AWES. We welcome you, Arun sir and Mrs. Punam. To the audience, I would like to let you all know your questions are valuable to us and are most welcome. However, in order to maintain the flow, participants are requested to write their queries in the chat box. Speakers will be addressing them towards the end. Also, we shall try to answer all questions, but if due to paucity of time some questions remain unanswered, we would try to address them through email. And may I again request all of you to switch on your cameras, please, because the recording is happening and we would like to see your lovely faces. So without much ado, let me call Arun sir to take over now and understand what are the goals of school education, what is information technology, and what is the basis for IT, how IT can be a part of school education in more beneficial way. Over to you, sir. Sir, you need to unmute yourself.
Thank you very much, Shikha. It's okay now? Fine.
Yes, sir.
As you mentioned, education itself is a very vast topic, and school education is also a very vast topic, and so is technology. So what we are trying to do, what I'll try to do is, will address a very limited and a focused area instead of going through the entire school education or the entire applications of technology. To start with, first of all, why should technology ever be taught in schools? See, technology is never taught in schools because it is very transient in nature. It keeps on changing all the time, and technology is application of some basic scientific principles to achieve human goals. So the basic scientific principles, physics, chemistry, mathematics, biology, etc., is covered in schools, but the technologies which are based on them, for instance, aeronautics, automobiles, then heat engines, and a number of them, for instance, shipping, fertilizers, biotechnology. These things are not a part of school curriculum at all because they keep on changing. Only the fundamental concepts of these technologies is covered. So why then are we talking about introducing information technology in schools at all? See, let's really examine whether it is relevant or it is not relevant, whether the technology should be covered at all or it should not be covered. Now, basically, if you see, information technology has grown by leaps and bounds and has advanced so fast and has changed the environment so quickly that we are all the time playing catch up. Why has it happened? Why has the environment changed so quickly, so fast? There are two main developments which took place in 1950s, which are the basic cause for such fast changes. One of them was the development of integrated circuit. That was in 1958. Again, in 57, 58, another development which took place was the launching of the Sputnik by Soviet Union. Now let's see how did this affect the changing environment, the development of the IC. Now for that, to understand as to why did it affect the change in the environment, one will have to go back to Charles Babbage. Charles Babbage, who is considered as the father of modern computers, somewhere in 1850s. So what did Charles Babbage do actually? Charles Babbage thought of making a machine which will do the functions of a human being. Now, what are the functions of a human being? A human being should be able to sense from the environment, remember what he has sensed, analyze what he remembers, and convey the results of the analysis to the environment. So these are the four basic functions that a human being does. And Charles Babbage thought of making a machine which could do these functions. Now, the technology available at that time in the 1850s could not bring into practice whatever Charles Babbage conceived. Now let's examine as to what all things are required for doing these things. So basically, how do we solve problems? How do we come to solutions of anything? That is, we make some statements, we connect the statements and build an argument, and with the help of statements and arguments, you solve any problem. So you got to have something which represents statements and connect those statements to build an argument. And as long as you can represent statements and arguments, you can solve any problem. So the statements could be, a statement can be either true or false. That means it has got only two states. So any statement can be represented with the help of a switch. And these statements could be interconnected. So excuse me, I think I should throw away this. Switched off. Excuse me. So you have to represent statements with the help of switches. And during 50s, this only switches which were available were mechanical valves. Then later on, the switches kept on being developed. The first useful computer which was made was an electrical computer which used electromagnetic switches. to represent statements. Now, the electromagnetic relays were also pretty big. So you reduced their size, it came to electronic valves, then transistors, and then finally, there are still improvements are carrying on. In 1958, Jack Kilby from Texas Instruments, he made a integrated circuit where a number of switches could be accommodated in a very small space. So what did it mean? It meant that you can have a number of statements and then you connect them with logically by
Excuse me, sir. Could you please unmute yourself? We missed a bit what you spoke.
Where was I last?
You were mentioning about the ICs being integrated, and now we have, yes.
Yeah. So somewhere in 1958, Jack Kilby from Texas Instruments made an IC which integrated a number of switches. So micro miniaturization of switches was possible as a result of development of an IC. Also, the logic was symbolized by George Boole. The predictive logic was symbolized by George Boole, as a result of which you could interconnect these statements with only 3 operators, and, or, and not. The net result was that we could make arguments to solve any problem and represent them with the help of a machine. The machine could solve any problem as long as you feed them with the problem and the solutions, the machine could do it. So the stored program digital electronic computer. What we are talking about is a stored program digital electronic computer. They became household machines. They were available. People at home could have them at home. In schools, colleges, etc. These machines could be used, and these machines then were able to. What actually it did was it rendered certain skills which are required for survival redundant. For instance, the skills required for gathering information became redundant. Gathering and storing information became redundant. Also, the skill required for solving a problem became redundant. So as a result of this micro miniaturization of these machines, the skills required for gathering information and skills required for solving a problem, they became redundant. Now, was there any new skill required? These 2 skills became redundant. Did it give rise to the development of some new skill? Yes. The new skill which became pertinent, which became important, was the ability to identify a problem that you want to solve. See, all information is available, all solutions are available, but you have to decide as to what problem you want to solve. So that itself became a skill, to identify the problem that you want to solve. And now the children at this stage, children in school, have also to be introduced to identify the problem that they want to solve. So that becomes a major goal of school education, to identify the problem that they want to solve. Then, and see, almost all schools they prepare the children for the basic 3 R's, then prepare them for admission in a college and some social behavior. This is what every school prepares the children for. But what is required now is that they should be able to identify the problem that they want to solve and work out ways and means, or find out the resources for solving that problem. Now, if they can do that, and if they have to identify the problem that they want to solve, we really cannot, nobody can tell them. They have to think for themselves as to what is the problem they want to solve. So introspection and the gathering of resources to solve the problem, taking decisions for themselves, these become important skills. And what we intend doing is, what we are suggesting is that at least in class 6, 7, and 8, please allow the children to think for themselves at least for some time. Because otherwise, they're all the time under instruction and they have got absolutely no time to think for themselves. So, at least provide some avenues or some scope for the children to think for themselves and identify the problems that they want to solve and allow them to solve the problems. And if they require some assistance, give the assistance. So that is what we want to focus in the middle school 6, 7, and 8. Why 6, 7, and 8? Because at that stage, the children are grown up enough to understand, and they do not have the board exam pressure at this stage. Because no matter how much you try, that pressure is going to remain, and it will take some time for the priorities to change. So at least to start with, let us focus on class 6, 7, and 8 and try to introduce some kind of try to encourage the children to think and identify their problems and find out solutions for the problems themselves. Now, I think I've covered the first part, and maybe I'll hand over to the moderator, Shikha.
Yeah, thank you, sir. You're absolutely right.
Yeah, go ahead. Yes?
Thank you. Now, so we should focus more on the fundamentals of IT at this stage, I guess, right? Okay, as sir mentioned that machines to be used by humans to perform tasks. So it means machines and humans need to communicate in order to solve problems digitally. So how does a computer solve problems? What is the importance of an algorithm or pseudocode? Let me call Mrs. Punam, who will be talking about the software concepts and how the identified problems by the students can be solved using these machines. Over to you, ma'am.
Thank you, Shikha. I hope I'm audible. Okay.
Yeah.
Fine. So, Arun sir had just told you about the contributions of Charles Babbage. Now, when Charles Babbage had developed plans for his machine that he called the analytical engine, he envisioned the engine as only performing arithmetic operations on the basis of some instructions. It was only his good friend and great mathematician, Lady Ada Lovelace, who was the first person to realize that a machine like the analytical engine could do something way more complicated than just one thing, and it could have abilities beyond just number crunching. Now, a machine that could manipulate numbers, could be made to manipulate any data that could be represented by numbers. and therefore it could be used to compose music, display graphics, and so on. Now, when she translated a French paper about the analytical engine into English, in her own annotations, she gave a way for the engine to calculate Bernoulli numbers in very precise steps. Now, this was a precursor to the current day program, and so we remember her as the first programmer. Now, you see, Ada was a true visionary because she was the first to realize that software had the power to add versatility to computers, the power to make them general purpose. Just by varying the instructions that were fed to the computer, we could make it solve a variety of different problems for us. And that is the way we know computers today, isn't it? As machines that solve problems for us. Now, to understand how computers solve problems, let us first look at what problem solving really involves. So let me explain using a real life situation. I noticed during tea time that my family does not seem satisfied with a plain cup of tea. I realize they also want cake with their tea. I detected a problem, absence of cake. So identification of the problem, as Warhadpande sir had also said, is the first step in problem solving. We should first be able to realize what the problem is, the fact that the problem exists. Only then can we solve the problem. Now, step 2 is to analyze the problem. Now, to bake my cake, what ingredients do I require? That is, what are the inputs? What do I want my final cake to be like? Soft, spongy. That is, what is the output? And finally, what steps will be required to translate the inputs, in my case, the ingredients, into the output, in my case, the cake? Now, this brings us to step 3, perhaps the most important step in problem solving, developing an algorithm. I now need to spell out the exact sequence of steps that have to be followed. That is, grease the container, dust it with flour, sieve 1 cup of flour with 1 teaspoon of baking soda, and so on and so forth. Because only when I know these steps clearly will I be able to execute the algorithm, that is, bake my cake. And last but not the least, I must check if the solution meets all requirements. Is my cake tasty? And rework on my algorithm if it isn't. Now, what if I do not wish to bake the cake myself, but I want my daughter to bake it for me? Then I must give her the ingredients, the inputs, spell out the step-by-step procedure, and then hope that she does a good job. Can you imagine what would happen if I do not give her the correct steps to follow or the correct order of steps? Imagine if she pours the cake batter in a container that has not been greased and dusted. Imagine if she bakes at 250 degrees centigrade instead of 180 degrees. Disaster. Now we want computers also to solve problems for us. So we must do the same here. We must provide inputs to the computer and also must spell out the steps that have to be performed, that is the algorithm for the computer. And here we need to be even more precise and accurate than I was for my daughter, as the computer would very strictly follow my instructions. If the algorithm is wrong, disaster. To summarize, computers are able to solve our problems only when we give them the correct inputs and also the correct algorithm. Now, this was a small example. We have umpteenth examples of incorrect algorithms leading to much bigger disasters than just a burnt cake, like the explosion of the Ariane 5 simply due to a design error in software. Therefore, it is imperative that we teach our students to appreciate the importance of a good algorithm. Not just because we would be able to instruct computers better, but also because algorithms are all around us. We must impress upon them the need for accuracy and correctness of an algorithm. We must teach them that there can be more than one approach to solving a problem, and hence we can have more than one algorithm for a particular problem, and one can always be better than another. We must also teach them the importance of testing the algorithm before execution, because we don't want any disasters, do we? But wait, Can the computer really understand an algorithm? Don't I need to write code? Now, when I shared the recipe for baking a cake with my daughter, I wrote it out in English because that was a language she understood. Similarly, when I have to share instructions with a computer, I also need a language to communicate. The computer understands only the binary language, the language of zeros and ones. So if I give instructions to the computer in the binary or the machine language, the computer will be able to follow my instructions. But most of us use programming languages like C, C++, Java, or Python. Why don't we use machine language? And how can the computer even understand instructions that have been written in Python if it knows only binary? Are there any helper programs for doing the translation? What are these called? In fact, why are there so many programming languages? Earlier, there used to be Fortran, Algol, COBOL, and now we have Java, Python, C#, and even newer ones like Groovy, Go, Swift. The list seems to be endless. Now, if the reason for using these programming languages and not binary is that these are English-like in nature and therefore easy to use, why not use English itself as a programming language? We must encourage our students to come up with questions such as these and help them in seeking out the answers. Now, let me state this again. We must teach our learners the art of designing algorithms in their formative years. It is much more important than the art of coding. Logic is always more important than syntax. A good algorithm may or may not be converted to good code, but a bad algorithm will produce nothing but bad code. They will need to use algorithms. They will be surrounded by algorithms throughout their life. While programming languages are transient, they will keep coming and going. We all assembled here are conversant with the English language. No, we know the language syntax. But how many of us can write a good story? Similarly, a coder is conversant with the programming language syntax. But can he write good code? Only if he can think of a good algorithm. So, why not empower our learners to weave beautiful stories in software? Well, thank you. And I think I will hand back the control to Shikha.
Thank you, Ms. Punam. I think you rightly said that set of instructions, which we call software, has the capability to perform beyond the capabilities of a machine. And I think it is very important to set the precise algorithm. And as you mentioned, algorithm in basic English would be much, much easier for our learners than writing a code in computer languages, which they will eventually learn if they want to pursue further. So I guess it more makes... I heard something. If you have any question, you can put it in the chat box. And I guess it makes more sense now how learners will take this forward to solve problems around them. Understanding hardware, writing an algorithm, and solve problems through machines. But computing and solving problems would be meaningless, I think, if not shared with people. As you mentioned, like you have shared the algorithm to bake a cake with your daughter. Similarly, when internet came into our lives, it was revolutionary, and today we can't even think a day without internet. So learners need to know how machines interact with each other as well. So can I call Mr. Arun again and to talk more about communication or communicating among machines? Sir?
Thank you very much, Shikha. But before I come to communication, I just want to stress upon as to why. I mean, to start with, I said, why should any technology be taught at all? And I sort of dismissed the introduction of technology or teaching of technology in schools. But I made an exception with information technology. So a little bit more about it. So for instance, Punam mentioned about the machines understanding only binary language, right? So you see, actually this particular subject can widen the horizon of the people and make them make the children question and sort of clarify their misconceptions or understandings, so that this doesn't remain a mystery anymore. For instance, these machines understand binary only. So why don't we use binary all along? Why the hell should we use decimal? What is wrong with it? Then why, for everything that we do, there has been a solid reason behind it. Why do 60 seconds make a minute? Why do 60 minutes make an hour? Is this binary? 24 hours making a day? 12 in a dozen? 360 degrees in a circle? Why? So I think we must ensure that the children start asking these type of questions. Now, if they start asking these type of questions, then only you are really trying to analyze things around you, and you are preparing yourself to meet all kinds of eventualities, so that they prepare for the unforeseen, and whatever they come across in future, they are able to reason out and tackle it. So for that kind of a development, this subject really can contribute a lot. So then I come to, okay, now I'll address whatever Shikha told me to address. That is, you see, you can solve problems, you can come to solutions, etc., but it's useless unless they are shared. So for sharing of information, the second aspect, that is the second development that I mentioned in the 1950s, the launching of the Sputnik, or an artificial satellite in 1958, that has removed the barrier in communication caused by the curvature of the earth. The earth is round, and that was a very big barrier in communicating across the world. So, how did the Sputnik solve this problem? See, by and large, for transporting information, like for transporting ourselves, we use some vehicles. For transporting information, we use electromagnetic waves. The electromagnetic waves propagate in a particular manner. So you have to, whatever information you want to transfer from A place to B, you make it ride on electromagnetic waves. When it reaches the destination, you get rid of the electromagnetic wave. So the electromagnetic waves are the carrier for all kinds of information. Now, how do they travel? How do they propagate? So the low and medium frequencies propagate along the surface of the earth. The high frequencies are reflected from the ionosphere. The very high frequencies follow a line of sight path. So you can communicate between 2 points which are not very far away, so that, and within the range of the electromagnetic waves, low frequencies and medium frequencies traveling. The high frequencies you can use for communicating between two places, but in between remains a gray area again, because the waves reflected from ionosphere will land at a particular place, will be reflected at a particular place and not all over the place. The very high frequencies, they will enable you to communicate with anything that you can see. It may be the moon, but you cannot communicate between, say, Bangalore and Delhi. because the curvature of the earth. So, how the Sputnik, launching of the Sputnik, or making an artificial satellite, putting it into space, if you have 3 geostationary satellites, you can cover the entire earth. And the electromagnetic waves travel with the speed of light. So, instantaneous communication across the globe is possible with the help of artificial satellites. So, 2 developments, that is, one is the development of the integrated circuit and the ability to launch satellites in space, artificial satellites in space. These 2 things, they have converted the whole globe or whole universe into a microcosm. And what we are living in now is in a microcosm, and some people call it the digital world. Now, digital world, why do they call it the digital world? Because everything is digitized. And why is it digitized? You see, you've got to know this as to why is it digitized and what is the if it was not digitized, then what would be the problem? So these are all mysteries which are spoken of left, right, and center, but very few understand the meaning of these. So I think the children these days must understand whatever they're talking about, and they should be able to think for themselves, identify their problems, and come out with solutions and solve problems for themselves. And that is what we want to encourage, especially in the middle school. And maybe we can devise our own ways and means to do, if we are convinced, you can probably find out ways and means of achieving this. I think for the time being, it's okay. I go back to Shikha for further directions from her.
Yes, you rightly explained the fundamentals of communication. I agree, it is very important aspect which is required for our learners to understand. They need to be good at computation and communication both, and they should understand what they are learning. They should know the basic behind it. And as you mentioned, why questions are so very important for our learners. Actually, children should identify the problems around them. They should ask why it is happening and how to find out why that particular thing happened. So they should be able to list out the steps of solving them and find solutions, everything on their own. I think that would make them real problem solvers. And they are already exposed so much to the information nowadays, which should be channelized in proper manner. So let me ask Mrs. Punam, how we can implement these projects in our digital literacy classrooms. Over to you, ma'am.
Okay, thank you, Shikha. See, sir has rightly been saying that we are living in a world which is constantly evolving. And the only thing that we know about our future is that it is very uncertain. So as educators, we have a very tough job, We have to teach our learners to solve problems, the likes of which we have never seen, using technologies that have not yet been created for jobs that do not yet exist, right? And that is why we want to give them an early exposure to problem solving. The best option before us is to teach them critical thinking and problem solving, because this is what is going to help them adapt and survive in this uncertainty, right? So what we are proposing is a very small step in this direction. The projects that the young learners will take on will be a medium for them to learn the tools of research, analysis, decision making, and even communication, right? So how to go about it in schools? As sir said, you simply ask the learners to identify a problem that they wish to solve and then solve it. And take my word, it is not really difficult. See, I was recently taking an online course from Cambridge, and they asked me at the end of the course to develop a small project that would solve a problem for me or the world. Right? Now, so I thought a little about it. Now, since most of my savings were in fixed deposits, see, I belong to the old world, right? And deposit rates had reached an all-time low during COVID times. And now they were increasing. So I needed to rethink my investments. And had been thinking about this since some time. Should I break my existing FDs at a lower interest rate and make new ones at a higher rate? Because breaking a FDC not only means that you will get a lower interest, which is applicable for the now shorter duration, but it will also involve a penalty. So it's not simple math, right? So I therefore did what? I created a financial assistant, a program that could analyze all my fixed deposits, and it could advise me the best course of action to take. And for the first time, I really felt proud that I could program, because I had managed to solve a problem for myself. I have mostly taught senior school students where project work is something which is confined to the subject curriculum. Still, it has been my experience that when the children are allowed to select a project of their choice, they feel that they are active participants and they always learn better. And the sky is the limit as far as their ideas are concerned. I had students develop speed flying games, shortest path finding algorithms, music playing apps, computer control lights, and the list is endless. In fact, I distinctly remember a bright kid who was not really putting in much effort in my subject, right? Who cheekily asked me if his project could be on a drinks bar. I said, why not? And not only did he learn all the programming that was necessary for completing his project, but I got another 90% on my rolls. So I think, children are very bright and they have a lot of ideas. The only thing that the teacher must actually do is just to get her students excited and inspired to carry out these projects. And I think the rest is going to take its course. So, that is what I sincerely believe.
Right, ma'am. So here, students would be choosing their own problems, and the roles of teachers is limited, I feel. So, Arun sir, how are we going to define some learning objectives or creating rubrics for this project, or it's just to be on their own pace and they'll be doing on their own? How students will be taking up these projects?
Yeah. A little more on what should be done on the projects, etc. You see, one has to realize that the only way you enjoy life is engaging yourself in activities which you enjoy. Now, the problem is that most of us don't even know as to which are the activities which we enjoy or what are our skills. So, in fact, it will be worthwhile stressing upon or allowing the children to identify their skills or their interests. Now, if you allow them to identify what are their interests and identify their skills and which are the problems that they would like to solve, probably if they can do that, half the battle is won. And unfortunately, what happens is we don't allow them to do this. So you could probably use these classes, just maybe 2 periods in a week, which are devoted to information technology, to give them the basics, fundamental concepts of information technology, and also allow them to identify their skills and take steps to enhance or gain some proficiency in the skills which they enjoy, And I'm sure by 6th, 7th, and 8th, 3 years, if they do that, they'll be able to decide as to what should they do in future in life, and decide for themselves and take decisions on their own and stand by their decisions. Yes. Now, what was the question you asked? Sorry. Yes.
The question was like, should we define, like, is it important for us to define some kind of learning objectives or create rubrics when the children are doing these projects, or it's like we are allowing them to do these projects on their own pace?
No, actually, we do not want to put blinders in any way.
Okay.
Let them do what they want.
Mm-hmm.
Let them achieve what they want to achieve, and if we give all kinds of help to achieve them, to help them in achieving what they want to achieve,
Mm-hmm.
and need not compare one's performance with another at all, because everyone is doing something independent in his own way. So challenging oneself should be the focus, and not competing with somebody else.
Right, sir. So may I
Right.
request you to switch on your video?
Oh, sorry.
No problem.
Yeah, so it's on. I'm sorry. Sometimes I don't switch on the video, sometimes I don't switch on the mic.
No
So
issues.
anyway, I think most of what we wanted to convey has been conveyed in a short while.
So we have a question. We have some questions from the viewers.
Yes. Actually, we would like to answer the questions, and I'm not sure whether we'll be able to answer them, but we'll make an effort to answer them.
Okay.
Yes, go ahead.
So let me take a question from Mr. Anurag Soni. He's saying that teachers worry that while the technology is engaging on a creative level, the students may be missing out on basic concepts like in math or in language. Children use laptops and tablets for their work and integrate things like Facebook groups into regular projects. And unfortunately, the school is also suffering from low standardized test scores. So how to tackle them? Is it to blame the technology?
Punam, would you like to say something?
See, to blame the technology, if you say that, I think it's just to put the cart before the horse. See, technology is technology. It is how you use it. Whether you use, I still remember. See, when my daughter was in class 8, she wanted, she was, participating in a competition, and she wanted a, there was that device during that time which would play songs. So she said, I'll do well in the competition, and please give me that device. So I decided that I would give her a mobile phone instead, right? I said, ultimately you need a phone, so I'll give you a phone, but I would like you to use it judiciously, and you decide how you're going to use it, right? So what she did was, she was fond of reading books. And when you read books, see, often you come across words whose meaning you don't know. She would use her mobile, for the purpose of using the dictionary and finding out the meanings of words. So she put that, a mobile to a very good use. So that is it. It's up to you what you do with technology. Technology is great. See, anything that you want to learn, you can learn nowadays at the click of a mouse button, isn't it? Right? So it is up to you what you're using technology for. And as elders, I think we just need to give guidance and channelize our children in the right direction.
Right. I hope. Yes, Arun sir, you want to say something?
Yeah, actually, one has to really understand that with the availability of new technology and new gadgets, etc., there are certain skills which will become redundant, and there are certain skills which will have to be acquired. So that preparedness has to be there. Well, unless that preparedness is there, you'll never adapt yourself to the changing environment. Have I answered your question, or something more to be done?
Yeah, Mr. Anurag, you can unmute yourself and can speak if you wish to. All right, let me take the next question. Ms. Sonika is asking how technologies can help in overcoming the lack of clarity about the purpose of school.
Very interesting question. You see, lack of clarity in the purpose of school. I don't know whether it ever existed and whether it will ever exist. See, just a quote from by Bertrand Russell, the great philosopher. He was talking about the school education across the world, and he said the British education system is all geared towards fighting wars, and the Japanese education system is all geared towards nation building. And I see no education system in the world which is geared towards human building. So, see, that is what Bertrand Russell said, and by and large, it still is true, and it will remain true. You cannot have solution to everything. It's a continuous process, and you will have to find out solutions as and when you come across problems. And that is why this, what we are proposing for class 6, 7, and 8, has to identify the problem and find out solutions. That skill has to be stressed upon, and you have to become adaptable. That's
Right.
it.
Right. So there's another question. I feel okay. Let me ask: how to align between technology, curriculum, and instruction?
Pardon?
Mr. Ankit is asking how to
Yes.
align technology, curriculum, and instruction.
Can you clarify the question, please? I couldn't really understand.
I think he meant that the instruction, what is required to teach technology, is it aligning with the curriculum, the curriculum of the school? So how to align all the three things together?
Okay. I think I have got the question. See, by and large, we do not want to. I'm not suggesting that we should disturb what is existing. For instance, that's why we are not touching physics, chemistry, maths, etc. Right? So, because if you start experimenting with that, you will spoil whatever is existing, and the new thing will also not take off. So, we are suggesting that in information technology, we can do this kind of an experiment where the basic concepts are focused upon, and the why of everything should be understood. And because it is a technology which is developed purely on logical concepts, there is nothing left to chance in that. And see, whatever you do, you see the result. So there, at least understand as to why we are getting these kind of results. So become wider in your thinking and sort of start questioning everything. Maybe you don't cover a lot of portion, don't cover everything, but whatever you cover, it's solid. So 6th, 7th, and 8th, that's why we are specifically talking about 6th, 7th, and 8th, and in this particular subject only.
Right.
This probably can filter into the other subjects. this kind of a thinking. So this is a clandestine approach for encroaching into other subjects, but not saying that we are going to disturb the other subjects.
Right, sir.
You're right.
Yeah. So Kanika Pant, she has written, the present framework you're talking about will surely lead students to think about and recognize their problems and corresponding solutions. Could we introduce a framework for students to recognize problems affecting the world or try solving them? Do you think that will be a good exercise for younger children? And how can we go about implementing that?
So
I think partially you have answered this, but yeah, please go ahead.
See, the moment you talk about framework and a structure, you're putting blinders on the person.
Right.
Let them think. Don't put any framework. Let them be free to think whatever they want, and let them try to solve any problem that they feel like solving. Don't put any framework.
Right.
You think it cannot be done?
I think it can be achieved as long as parents are convinced and school management is convinced. So there's a question on this. Are these projects to be an add-on to the normal studies? Or I think Mr. Ajay meant, like, are we going to add these projects along with the curriculum we are teaching? Or this would be entirely standalone?
See, now when you talk about curriculum, again we have taken this topic, taken this subject because none of the boards lays down a curriculum for this subject in the middle school. That's why we have taken up this particular subject, and I do not suggest we disturbing any existing curriculum. That is independent, and this is an independent activity.
Right. So, Miss Aditi is asking, how does exposure to and use of technology in school affect future employment?
Yeah, very good. This is a wonderful question.
Yeah.
So basically, the goal of schools, is it to prepare somebody for an employment in a particular area? You see, school is meant for making a foundation in various subjects and making the child confident enough to decide for himself as to which course he is going to follow later on in life. So we are not really preparing a child here for future employment. In a school, the goal has to be to prepare a child to become confident and find out his way in future life.
Right. Yeah. So Daryl is asking,
if I can add to that, Shikha,
Yeah.
It's also that, as I had said before also, because of the fact that things are changing so fast, we do not even know what future employment is going to be like, right?
Agree,
So
agree.
it is kind of impossible to to prepare a child for a specific kind of future employment, because that employment itself is not going to be there when he passes out of school, right? So we have to give him the skills that will be required for him to do well in any kind of employment that he gets later in his life.
Yeah, right. Rightly said. So Daryl is asking how to launch Sputnik from home.
How to? No.
Launch Sputnik Digavali from home.
No, who's that? Please, can you clarify your question?
Daryl? Okay, the person left the meeting.
Huh?
Okay, the person left the meeting. Okay, I'm taking the next question.
Yeah.
Mr. Ajay is asking, how can we partner and initiate in this case?
How can we?
So, how can we partner? I feel he's interested, and he's asking, how can we partner and initiate these kind of projects in the school?
Very good. Is he there?
I'm there.
Huh?
Yeah, I'm there. I'm there.
Yeah, Ajay. Yes. Please repeat your question.
See, I wanted to know how we can initiate in this case, be it at the school level or be it at the actually, suppose we are consulting on schools also in that manner, how we can take it to multiple schools.
Yeah. Okay. You see, to start with, we start at home.
Right.
Right? That if you think about doing it in multiple schools and bringing it across all schools, you'll end up in frustration. Right? So you can at least do it with your school, start it with your school, and then the others may follow your school. They may learn from your school. But whether they learn or not doesn't matter, because at least you have done it. So charity begins at home, basically. Yes? Is it okay?
Okay, it's okay. But I need to understand what is the process to initiate into it?
What is the process for initiating it? Shikha, can you elaborate? Because we have already started or making an effort to start this process of initiating it. Can you throw some light on that?
Sure, sir. So, Mr. Ajay, I work for Valistus International School, and we had a couple of meetings with the Arun sir, where sir explained about these projects. So here, learners need to think what they feel around them. So we give the thinking cap on the students only. So they think, for example, someone is not coming on time to board the bus. It's a simple problem. Or as Ms. Punam mentioned about different problems. So they identify the problems, and then we will ask them to write the steps to solve the problem. Now it's kind of algorithm, but they're not writing into any kind of computer language or any kind of syntax or any kind of computer algorithm. They're not making. They're just writing simple English steps, step by step to solve a problem. For example, a person, Ms. Punam had mentioned, I guess, like a person has to withdraw money from an ATM machine. So what are the different steps for the person to go to the ATM, withdraw money? So what are the kind of instructions the display machine is giving it to you? So these instructions, step by step, the child has to write, and the child has to present it to the peers, and they can have this project. Then after finishing this project, they can take up another one, which they feel there's another problem which he or she has identified near him.
No, suppose the problem is identified. Now the steps also are written by the child. Say 5 steps or 10 steps, whatever they feel to overcome that problem. Then how to take? See, after that, what can we do?
No, just a minute.
Yeah.
Ajay, I think there are two things, two separate things here. One is that you have identified a problem and you're trying to logically solve it. But this problem which is being mentioned here is not a problem which has originated from the child. What I mean to say is, I'll just give you an example. In one of the schools, I told the teachers that let the children identify what problem they want to solve, and let them make an effort to solve those problems. So first of all, it was quite a task for the teachers to accept that the children will come out with problems of their own and which they were to solve. But once they accepted and they posed this question to the children came up with, class 6 children, they came up with 70 problems which they wanted to solve. And the problems were so diverse that one could never imagine that they can come up with problems like this. For instance, the problems were, why are younger siblings so irritating? Why are parents hypocrites? Is religion necessary? What are black holes? 70 problems like that came up from the children, class 6 children. And the teacher said that these are stupid problems. I said, none of them is stupid. Let them do some research, let them find out the solutions for this, and let them come out with a presentation on this. I tell you, the children thoroughly enjoyed this exercise over a period of 3 months, and they came up with presentations on each of these topics. Now, can you imagine an exposure to 70 different topics within a period of 3 months shared by the children of class 6? What better exposure can there be? So you see, this is one aspect, and this we want to club it in these 2 periods. So not related to information technology. But basic idea is to make them independent thinkers.
Right, then why we are calling it IT? Why don't we call it actually, why don't we call it basically some different name? We have to, I feel...
No. Why we call it IT is because we are also including information technology in this, and we're going to use information technology for solving these problems. So the practical application is also going to come through information technology. You're going to use information technology for everything. So one is give them the basic concepts and also let them use the technology, but don't tell them as to what they should use. For instance, I'll tell you, the children these days, they are digital natives. We are digital immigrants. They know how to use technology. You don't have to tell them how to use technology. So let them leave them free, let them identify the problem. That is the biggest problem. Let them identify the problem and find out solutions for those problems. So use information technology for each and everything, doesn't matter, and it will be required. Yes, some more discussion?
No. But I would like to basically have some more info to...
Yeah, sure. You see, now I think I have your email. Maybe I'll make an initiation towards you, or you can drop me a line, and we can probably take this forward. Right? Where are you, Ajay?
See, I am basically based out of Delhi, but I am working with 1 or 2 schools wherein I am helping them in total transformation.
Okay.
So that's what
very good. So we can probably interact more on this,
right,
and develop the idea further.
Right. Thank you.
Right. Any more?
That's it.
Any more questions?
We have no more questions from the audience. If someone wants to ask something, you may unmute yourself. Okay, I think, shall we conclude the session now?
Yeah.
It's already 6:12. Yeah. So thank you so much, Arun sir and Mrs. Punam, for your insightful thoughts. And thank you all for spending your valuable evening with us and understand whether we are giving the right kind of digital education to our learners. So let's ponder more and reflect and make our learners real problem solvers, where they will become more confident and in turn ready to face the life ahead. Thank you so much, everyone. Have a happy evening ahead.
Thank you,
everybody.
Thank you.
Bye.
Bye.